A very good afternoon to everyone. My name is Suhaimi once again from BEX Asia, organized by RX Singapore, and I trust every one of you had a very good long weekend break. It's always nice to have a long weekend, so we're back in the office here today. And thank you for taking the time to attend the masterclass today, presented by Camfil. So we are very pleased to have with us today Mr. Joe Lee for Camfil. And Joe has joined Camfil since 2014 as the Business Development Manager. He provides clean air solutions to customers for solving molecular contamination issues and improving air quality. Joe holds a Bachelor's of Business Administration degree from University of South Australia. And prior to joining Camfil, he worked in surface mount technology industries across Singapore, Malaysia, Indonesia, Thailand, and China. So, Joe, can I invite you to come on camera and say hello to every one of us here? Hello, Joe. Good to have you with us.
Hi, good afternoon, everyone. Thank you
Right.
for taking the time to attend this webinar.
Okay, ladies and gentlemen, now without a further ado, let's start the session. But if you have any questions during the sessions, please feel free to use the Q&A function in the webinar to send your questions across, and we will take the time to address these questions at the end of the webinar. Now, Joe, it's over to you.
Thank you. Before we start, a big thank you to everyone for taking your time to attend this webinar. There's a brief introduction from Mr. Suhaimi. My name is Joe, and I joined Camfil since year 2014 as a Business Development Manager. In Camfil, we believe clean air is a crucial part in a human life, and we want to make it as a human right. Clean air will give enhance the employee health and the productivity as well. So we want to make sure that clean air is a human right, just like when we consume water. Camfil AB is a Sweden company, and we are located in Stockholm. This year, we are just nice. I think coming into a few more days, we will be 60 years old. So we have about 5,200 employees worldwide, 31 manufacturing sites with 6 extensive R&D center across the world. The nearest one being in Ipoh, Malaysia, to serving our valuable client in Singapore, in Asia regions. And we have more than 35 countries with sales offices. And of course, the man on the right is our CEO, Mr. Mark Simmons. We have 4 business units in Camfil. Filter is the integral part for all the divisions. So HVAC being the general ventilation system, we are serving our client in comfort, in a clean room, in industrial and containment as well. So not only the clean air solution provided by Camfil is being sustainable, it also brings great saving and benefit to our client in terms of energy saving and long service life. The next will be the air pollution control. It's a business unit whereby when the dust loading is huge and a lot of mitigation of dust need to be done before the air being exhausted out to the atmosphere. So we can, industrial fumes, dust, and mist collection segments. The other one will be the power system. From air inlets up to the acoustic system, we have the clean air solutions for our available client depending on the needs and the requirement. So the other value-added services by Camfil for the power system is we did a site assessment. We actually send the used filters to our lab in R&D, Ipoh, for analysis and also to study the service life of the filters. And of course, we have a chem lab that is very portable, where we can actually tow it right to the site of the the cogen, where we can do an actual LCC, life cycle cost, to find the actual site conditions and challenge your filters to know the service life. The last but not least is the molecular contamination control unit system, where we are talking about harmful gases and all those. So unlike particle filters, these harmful gases need to be um, handled differently via different kind of filtration principles. And we are in this oil and gas, healthcare, and even those pulps and paper industry as well, biogas. Yeah. So let's start on the ISO standard. What is it in for you? ISO 10121 is the first and it's a new standard that's been classified. It's mainly for classification of the molecular filters for general ventilations. Having said that, it's actually referring to comfort applications. It's a big step for the market and for the stakeholder. In the past, where we talk about the molecular filtrations, it's either a yes or no, but there is no classification at all. So what kind of efficiency, what kind of lifetime that we're talking about, there's no definite classification on it. So with this standard, we'll be having this very definite and clear classification for various filters targeting different gases. With this standard, we can also compare many different type of filters against 4 different gases. So it's the direct comparisons, and you can see the performance of the various filters versus the various gases in terms of capacity, in terms of lifetime. Like I mentioned earlier, in the past, you know, when we when the consultant, when they spec for molecular filters, it's just well, do we need a molecular filters? Yes, we need, but what kind of efficiency, what kind of classification is unknown. So with this standard, you actually bring things more definite and more clear to the industry. What kind of gases you want to be targeted, and also what kind of classification you want to classify. And of course, you set a minimum requirement for molecular filter in AHU applications. Just like, you know, existing these particle filters using the ISO 16890 standards. Okay. Why are we targeting this gaseous contaminations for the outdoor air? If we were to look at the statistic and previous studies, you will see that these are the 4 harmful gases that have direct impact on human well-being. So the ozone, the NO2, meaning the nitrogen dioxide, the SO2, which is sulfur dioxide, and toluene is a volatile organic compound, which is mainly referring to odor and smell. And that's the reason why for this ISO 121, they are actually targeting on these 4 gases because it has direct impact on human. So what is a guideline? When we talk about the air quality, we will actually talk about guideline and the ventilation standards. So the first thing that we refer is, of course, the WHO standards. WHO have many have been in the market for very long, and of course, the most recent is actually 2021 versus the last standard that they implement is 2025. So if you were to look at the PM 2.5 and PM10, which is the dust, they actually make a reduction from 10 microgram per meter cube to 5 for PM 2.5 and respectively for PM10. But what about the in the past when 2005, there's no mention on ozone at all. So based on scientific study, WHO must have recognized that ozone is harmful to human, and that's why in 2021, they actually include ozone to be inside there. Okay. And for the NO2, you can see there's a significant reduction from 40 microgram to 10. Okay, so for the particulate matters filtrations, we have a very recognized global standard with ISO 16890, where we talk about EPM1, EPM 2.5, and EPM 10, where we can relate on the kind of efficiency and the target science that you want to filtrations. And with that, then we can bring that standard to applications, whether is it a European, or even a global standards. But in the past, there's nothing for molecular contamination at all. So having said that, and we are lucky, we are glad to announce that now we have this ISO 10121-3 to do the classification of the molecular filters. And very soon, this standard will be just like ISO 16890 will be bringing into the application standards. The panel the panel have been working on it, and it should be implemented soon. So what kind of timeline that we are looking at for molecular filter classifications? The standard actually developed since in 2019, which is about 3 years ago. And after 3 years of hard work, yep, the ISO standard come upon with 2022 and the European standards. So just 3 days ago, about 30th of April, we are glad that national standard EU have actually implemented that as well. So on the graph here, on the right hand side, you can see there's a VDL, VLD, LD, MD, and HD. So different kind of filters design will have different kind of capacity and lifetime to target different kind of gases. So we will cover a little bit more on this in the next few slides. ISO 10121 have 3 parts. So the first part and the second part is actually assessing the performance of a gas phase air cleaning media and the devices for general ventilation. And the part 3 is actually for classification system for GPACDs applied to the treatment of outdoor air. So what does a GPACD stand for? It's actually just referring to gas phase air cleaning device. So in layman term, we can just call it as a molecular air filters. Okay, so you can see this part 1 is actually testing of air cleaning media for ISO 121, and part 2 is actually cleaning devices, which is our air filters. And finally, part 3 is actually the classification system for the GPACDs. It's good to have all the standard, but we also want to be clear on what does this standard apply to very strictly. Take note, this ISO 10121-3 is clearly limited to comfort applications only. So it's actually referring to GPACDs supplying single pass outdoor air to general ventilation system. Okay, and it's actually supplement in addition to the particulate contamination dealt with by ISO 16890, which is your particle filters. So actually it's an add-on to the particle filters that you have. So again, the 4 contaminants, the pollutants that we target is ozone, sulfur dioxide, nitrogen dioxide, and toluene. So in particular, GPACDs for this standard does not apply to recirculation applications or even those higher end requirement like clean room, pharmaceuticals, microelectronics, nuclear, etc., etc. So again, it's for comfort applications and it's for single pass outdoor air to general ventilations. Okay, so this slide actually will show you the test jig of ISO 10121, which is located in Camfil, Sweden. So we have about 4 of this test jig globally, and of course the nearest one is in Camfil, Ipoh. You start from the right, where you can see the air inlet. Oops, I'm sorry. The air inlets coming in from down this way, and then this rectangle piece is actually where the filters are being located. So the air with the contaminants and also dosage will be pumping in this way, and then outlet to this way. And you can see there will be a measurement sensor over here in the upstream and the downstream side to determine the concentration and the efficiency. Okay, so the test method overview. This is just an overview. Yep. So we will cover that in more in details in the next few slides as well. So it will be tested against 4 reference gases. The first test will be, of course, the initial efficiency for the respective gases. So you need total of 4 filters for 4 different kind of gases. It's not one filter against all the 4 gases. The second step, the second challenge will be the efficiency versus the dosage for the respective gas. So we will pump in certain concentration level into the upstream side of the filters to challenge the filters, and we measure the efficiency of the filters at the downstream side. As soon as the efficiency drop below 50%, the test will stop. Okay. And from there, we can actually classify each reference gas for each filters from light duty, medium duty to heavy duty. So shall GPACD, a molecular filters, do not qualify for light duty, it will be classified as very light duty, VLD. And we actually also did the calculation of integral efficiency. That's the area under the curve. We'll show you for the respective gas and a class. And we round it up to 5% increment, where you can see example on the right is actually toluene, LD, meaning light duty with 75% efficiency. So you won't be seeing a classification that tell you 72% or 78%. It's either 70, 75, or 80. Like I mentioned earlier, each molecular filters, GPACD will have 4 classes in total. So each class for each gas. So analogy between the ISO 10121 and the ISO 16890. By now, I think all of us must have been very familiar with ISO 16890, where we talk about EPM1. 60% is referring to 60% efficiency on particulate matters size PM1 and above. Shall the efficiency fall, and the cutoff point is actually 50% as well, for just to share. So shall the efficiency does not meet 50%, you will go to the next lower level, which is EPM 2.5, 60%. For this ISO EPM1 60%, you can see on the right, it's actually correlated to ozone HD 60%. We will show you what does it mean and in a few slides later. And well, take note, even these filters for this particular filters, maybe for ozone, it can do a HD 60, but for the other gases like maybe SO2, it might not be the same kind of classifications. So EPM 2.5, 60% will give you ozone MD 60%, medium duty. So the next level will be EPM 10. You can see is LD, ozone LD 60%. Last but not least, cost 30% is actually VLD, very light duty 30%. Okay, so this will actually determine which kind of filter standard for what kind of pollutants. So for here, you can see ISO 16890 particle filters, EPM1, EPM 2.5, EPM 10 in cost. So example, these filters over here is actually ISO EPM1 70%, meaning it can remove 70% of PM1 with these filters. So if you have 100 particles in the upstream, there will be only 30 particles escaping from the downstream side with this 70%. And for the molecular filters, ISO 10121, the four gases is shown here: NO2, ozone, SO2, and toluene. So example, NO2 LD 70% is actually referring to light duty. Remove 70% of the NO2 with these filters. So light duty, what does it mean? Later we'll explain about it. Yep. And in this case, if you were to look at this, actually this product is actually from Camfil. It's a 2-in-1 filters. It's a CD cup I, where we have both particulate metals F7 filters, EPM1 filter media, and the carbon media. So the carbon media is actually being sandwiched in between this EPM1 media in one single stage. So you actually save up the space on the AHU design. Okay, so now we talk about more details in the initial efficiency, the first step, the challenge. So these four gases in the formula, and you can see the challenge level is only 150 ppb, 450, 450, and 900. Why is it so low? So the reason why we capture this value is actually based on the current outdoor air conditions in the general conditions. So most of the time for outdoor conditions, this will be the kind of level that you will get for the various gases. And that's the reason why we input the challenge level in this for the initial efficiency. Then the next step will be challenging. You can see we actually pump in ppm, part per million, versus just now was part per billion. So for ozone, we actually pump in 3 ppm, and the rest is 9 ppm. Okay, the reason why we are only pumping in this 3 ppm dosage into our jig is because ozone is a very corrosive agent. So if we were to pump any higher ppm level inside this jig, that will cause some damages to our test jig. So that's the reason. Of course, with this 3 ppm, it still can be tested. It's just that the time that we take to test the filters will become longer. Yeah. Yep. So now is the classification of the LD, the dose limit for LD, MD, and HD. What does it mean? Actually, this are referring to the set of multiples of mole per meter square of phase area. Okay, so for LD, it's actually referring to 1.5 mole, 1.5 mole of the per meter square of phase area. MD is 6. You can see actually it's 4 times of LD. And then for HD is 24, which is another 4 times of MD. And if you were to look at the table, on this part on the left hand side is actually referring to mole per unit. So 1.5 mole for all the gases, but if you were to look at the grams per unit, it's all very different for different kind of gases. So different gases have different kind of weight, even though the mole size is the same, the mole per meter square is the same. Yeah. So when we challenge the filters, we actually put the LD, meaning we put 1.5 mole. I mean and the next slide we'll cover into that more details. Yeah. So for time being, just take note, LD is actually referring to 72 gram, which is 1.5 mole for ozone, MD is 6 mole, which is 288 gram. And last but not least, is actually HT is actually 24 mole, which is 1,152 gram of ozone. Okay, so the doses LD, MD, and HG, they're actually referring to the lifetime of the filters. Lifetime of the filters. So LD actually is referring to relatively short lifetime because the filter have lower capacity. Okay, and MD is actually referring to 4 times higher lifetime of LD. And HD is actually 16 times higher as compared to LD. Okay. So percentage value indicate average. I mean, this is quite straightforward. LD 60 meaning 60% of average efficiency, and MD 60 is the same thing, 60. The last two figures there is actually referring to the average efficiency over short time, medium time, and long time, long lifetime. So for if you were to classification of molecular filters, you can inside you can see if they say ozone MD 60, is actually referring to 60% efficiency, average efficiency over lifetime, and with medium capacity and medium lifetime. And these are the various examples for VLD, LD, MD, and HD. You can see on the right at the top, the HD, which is a cylindrical cartridges. This is actually a CanCap CG product from Camfil, where we actually using a loose field carbon solutions for heavy usage and heavy duty usage. And the MD is actually using a compact filters, which have a massive media area, and of course with a massive media area will have massive capacity. And the filter panel LD and the VLD will depend on whether this filter is how many inches. Is it 2 inches or 4 inches? Okay, this is just an example. Yeah, and then the pollutant we actually based on ozone. All right. Initial efficiency, 1.5 mole is actually at 99%. So the next challenge when we pump in MD, which is about 6 mole, point number 2, you can see actually the curve drop down to about 92%. Oh no, the 92% is actually referring to the average efficiency of this filters, which is under this curve. If you were to calculate the average, yeah. So, and before you hit the HD level, you can see the graph actually drop below 50%. And then of course, from there, we stop the test and we classify this filter as MD, meaning this filter can handle up to about 6 mole with 90%. 6 mole. So 6 mole will actually, there might be a question like, hey, Joe, what is 6 mole? How do you interpret? It's actually, it all depends on your outdoor condition, what kind of contaminants and what kind of level that you have. And then with that, will be easier to correlate these filters, the lifetime to your current conditions. And of course, unlike particle filters, the lifetime of filters can be determined by pressure drop, but for molecular filters, throughout the lifetime of the filters, the pressure drop will always be constant. So to analyze the service life of these molecular filters, an analysis of the media need to be performed. So this can be done with our Camfil extensive R&D center located in Ipoh, where we will send the sample, use filters back to our lab, and then we do the analysis for you. And then we, of course, come up with a comprehensive report. Okay. Take note, this is just another example B, where we talk about SO2. Just now was ozone, now we talk about SO2. So initial efficiency is very low, you can see. Right at the start, it's only about 73%. And before we even hit this this MD, 4 mole, 6 mole, 4 mole, you can see that actually the graph dropped below 90%. So this city pleat filters on the right here will have low, we have light duty for SO2 pollutants, and the efficiency is only about 55%. Because if you were to take the average efficiency from initial up to the point that's number 2, LD, the average is only 58%. So 58% we'll classify that as 55%. This is just another example. I think it's a bit quite dry, but bear with me. I'm going to finish. Of course, if you need any further information or any further explanation, well, feel free to contact any Camfil representative, and we'll be there to go through with you. Yep. So this case study, this example is actually talking about VLD. So NO2, right at the start, you can see actually the initial efficiency is already very low, below 50%. And that's why it has been classified, and it's not even hitting this LD level. So it cannot be classified as LD. You have to be classified as VLD for NO2. And it's only 25% efficiency. So depending on, really is all depending on what kind of contaminants, what kind of pollutants that you are that's your concern, and then what kind of concentration level that's present, then we'll use the right appropriate solutions for you. Last but not least, this is an example D for toluene. And this is our heavy duty solutions, molecular filtration solutions, and toluene being the VOC, which is referring to smell and odor, that very common happen in this bin center, etc. Initial efficiency is pretty good. It's about 95. Yep, 95%. So at MD is still doing very good. It's still well above 50%. And when we pump more into that filters, which is a HD level, and you can see the filter actually drop below 50%. So we stop the test from here. And the average efficiency from initial to this point where it dropped below 50% is about 72%. So we have to classify this as 70% in HD, because the top point is after HD. Yeah, so this filter is classified as heavy duty. Okay, so these are the various filters, Camfil clean air solutions in the market. For city flow and city pleat, 2-inch is actually more referring to light duty and very light duty applications. So you can see for for the 4 different gases, they have 4 different classifications. Okay, and the city cup and the city pleat with 4-inch actually is the MD series over here. Okay, so if you are more concerned on the smell, toluene, and you might want to consider probably this range of product over here, city cup and city pleat. And last but not least is A. And the other one will be the HD series, will be the city cup I and the city flow. City flow and city cup is actually 2-in-1 solutions. F7 with molecular filters inside there. You can see it's higher efficiency, 80%, and 85% versus 70% and 65%. For more information, please visit camfil.com, or you can just go to Google and type molecular filtrations, and they will divert you to this page where you will have this more informative materials on the website. And of course, we have this ISO 10121 brochure ready for your download. Yep. So in summary, ISO 10121 Part 3 is the first classification system for molecular comfort filters. It's the first, and it's a new one. It's a big step where we talk about molecular filtrations, where you can actually be more specific on your classifications, whether what kind of pollutants you are targeting, and also what kind of level, what kind of capacity. Is it a LD, MD, or HD, or what kind of efficiency that you are targeting, 70%, 80%. So it actually empower you to select the right molecular filters for specific comfort applications. And you can see just now from the slide, from different kind of filters, model and brand, you can see different kind of performance and different kind of classifications. So I would like to take this chance also to introduce the Chief Ergonomics Officers, which is Camfil is adopting. Just a quick question: what do you think? Does the air quality in Singapore, does it meet the WHO guideline? It's a question that you have to maybe think about it for a few seconds. Well, the air quality in Singapore is good, relatively good for Southeast Asia. And then the annual average PM 2.5 is about 10.9 microgram per meter cube. Okay. But this level is still more than 2 times above the new WHO limits, which is 5 microgram per meter cube. So, interesting study, reducing the WHO limit. By meeting this WHO limit, you actually increase the life expectancy of Singaporean by another 6 months. Yeah, so it's something that I think all of us should be concerned. Yep. And on the right, this is actually the map of Singapore showing you the level, and you can see we are classified 110. We are ranked about 110 out of 240 countries, which is not so good and not so bad. Yeah. So what is CAO, Chief Economic Officers? Just like any organization, you have a CEO, Chief Executive Officer, we have a CFO and COO, which is running the operations. But when you come to the indoor air quality, obviously there's a big gap because it's intangible and nobody can see it. So nobody really care about it. So this CEO actually respond to this gap by emphasizing the importance of good IAQ inside the office, and invites all party, whether is it the CSG, whether is it the production workers, whether is it the management level, apply all party to take accountability of the air that we breathe by appointing this CAO or AO in the organizations. So ergonomics actually came from the words ergonomics. So it's just that you have a clean air content inside this, and so using the clean air to protect people, process, and business activities. So in short, this CAO or AO is a person who promote the need for clean air inside in the workplace, and ensuring that clean air at the workplace by putting the necessary investment and the necessary implementations. Shall an employee have any concerns or question on the IAQ? this CAO or AO will be the one to support the idea and also to resolve the issue and work with the various HR and officer or facility manager for a better solutions. So this CAO and AO will be the voice of clean air because air, like I mentioned, is intangible, it cannot be seen. So we need somebody which is a CAO and AO to be the voice of this clean air. So do join us to be one of the CAO or AO in your organizations. This is we have, as of now, we have 600 members and still going on counting. If you were to go to LinkedIn, and you just have to type this Chief Economic Officer, and you can see this page. So, or you can go to the website and key in this link over here, and you will just be able to join us to be one of a committee. So with this committee, you will be able to, you will have a lot of resources on IAQ, and you can actually also post your concern and post your question on your IAQ on this panel, and then somebody will actually help to get back to you. Yep. Also, this CEO podcast. There are many. Just go to Spotify, which is very common now. Lock it in, and then go to this podcast. You will join us. And you can see there are so many streaming, like 700 streams in this CAO. Thank you for your time. This that will be my last slide. So now we'll be in this Q&A sessions.
All right. Thank you, Joe. That was a very, very educational presentation, especially giving us an update on the latest standards. And I think it's also very important, that you raised the role of the Chief Ergonomics Officer, right? Because even in Singapore, with our relatively clean air, the Singapore government is seriously looking at regulating indoor air quality, right? We heard about that earlier in the year. So we actually have quite a fair bit of questions from the audience, both those during registrations as well as a couple of questions that's come in from the live audience. So Joe, what I'll do is I'll take a couple of questions from our pre-registrations, and this can be quite general questions, while we will take the more technical questions a bit later on. Right. I think one of the general questions here is on the frequency of changing the filters and is it washable? I guess this is to see whether we can prolong the life of the filters. How frequent must you change the filters and are they washable?
Yeah, this is a very good question, and it's a very commonly asked question as well. The frequency of changing the filters is very subjective as it's against the type of contaminants and the type of filters that you use. There will be not any generic performance between two filters as it depends on the manufacturers and the quality and the standard that they abide by. So we do not recommend filters to be cleaned or washed, as once washed, the efficiency will reduce tremendously. Yeah.
I see. So it's not something, it's more about the quality of the filters that you purchase, and it's not something that you can wash and put through pressure washer, things like that, right?
Yeah,
Okay.
right.
So the next question is would be the molecular filtration relevance in general ventilation and what standards to apply on an electrostatic filter.
Okay. Applications for this molecular filtrations like lab, kitchen exhaust, and bin center, they actually require these molecular filters that deal with odor, which is toluene that we covered previously. So this will be the kind of general ventilations. But for electrostatic filters, they actually use another kind of principle of filtrations. So having said that, we do not see electrostatic as the filters. Yeah. So electrostatic system will still require a Tennant filters, the so-called Tennant filters, to collect the dust right after the electric wires. So that's the reason why we don't call electrostatic is the filters. Yeah.
I see. Now you mentioned something about VOCs on toluene, right? So why do molecular filters focus only on the four gases, that being primarily nitrogen dioxide, sulfur dioxide, ozone, and toluene VOCs? Why do they only focus on these four gases?
Oh, the reason is simple, because the WHO have actually recognized these are the four gases that will have direct impact on the human well-being and the productivities. So these are the four gases that we would want to follow together with WHO guideline. Yeah,
So this is the 2021 WHO guideline, which you shared earlier, where they added ozone and VOCs, right?
yep, right.
Right,
Thanks.
that's right. Now, the other thing, I guess, will the filter affect the airflow of an AHU?
Yes, definitely. Any obstacles that you place along the airstream will definitely affect the airflow. Therefore, the initial design has to be considered uh, the total exit resistance, whereby filters with low pressure drop across the entire lifespan will save more money, will save more energy for the system AHU, the air handling unit. However, only particles captured in the filters will increase the resistance. Um, Molecular filters having a chemical reaction, which is another kind of principle, um, with gases will not increase the resistance at all. So only the particle filters will increase in pressure drop, but not for molecular. So um, in cases when there's no particle filters protection in front of the molecular filters, of course, the dust will be entering and choking up all those molecular filters, and then definitely the pressure drop will rise. Yeah.
Yeah, so this is something that we need to think of from the very start, right? Making sure that we design the system as efficiently as possible,
Yes, you're right. You're right.
right? Now, you mentioned earlier that for GPACDs, this is a live question that we have come, someone we has sent in. The GPACD, correct me if I'm wrong, but you said this is primarily for outdoor air single pass to indoor ventilation, right? So what then do we do with the return air which is circulated?
Uh, in that application wise, this classification, the ISO 10121-3 might not be applicable at all because it's another application. It's not a single pass supply general ventilations. So with the recirculation system, of course, Camfil have our own set of clean air solutions to target the various concerns, whether is it H2S, whether is it SO2, and what kind of airflow that you are looking at, and what kind of air change that you need. Yeah, so we will study the concentration level. That's the basics. To identify the various contaminants, the pollutants, and then we find out the expectation from a client, what kind of ppb level that you want to achieve within the indoor. Then we will work out the required solutions for the client. Yeah, so there will still be solution. It's just that this ISO 10121-3 will not be applicable. Yeah.
I see. So this is where your service as a, not just selling filters, but also providing consultancy and advice on what are the best solutions possible to clients, right?
Yes, you're right. You're
Right.
right. Yeah.
So you mentioned the new ISO, 121-3. Will this be part of SS 553 or 554?
Definitely, yes, definitely. We believe strongly the authorities will adopt this system very soon. But it will take some time, definitely. Yeah.
Yeah, I guess the authorities need to consult the industry also on readiness and all, but we good to know that Camfil already has a ready solution for that, right?
Yeah. Thank you.
Yes. Quick question from the audience, live audience. Is this filter only for the outdoor air filters?
Mm, this filters only for outdoor air filters. Uh, Actually, for this any filters, you can use it both for indoor or recirculation or outdoor applications. It all depend on your current installations. Uh, Well, if let's say if it's actually based on outdoor applications, definitely you need to have some particles filters, whether is it EPM 10 or EPM 2.5 filters right at the front before the molecular filters to protect your molecular filters lifetime. Yeah, definitely. I can't hear you, so I mean.
Oh, sorry, I muted myself. So another question from our live audience here, right? So thank you, Joe, for the insights here. But for these filters, how do we know what is the conditions, contaminants that we can use to select the right filters? Then the follow-up question was, can these filters be retrofitted into existing AHUs? And the third part of the question is benefits of using a filter from ISO 16890 versus 121-3. So maybe you want to, I guess the first part of the question would be how to know what is how to select the right filters based on the conditions and contaminants.
Yes, correct. The, like I mentioned, the first step will be the basic to know the current outdoor conditions. So what kind of which area are you located? Whether is it in the city area or is it in the industrial area? They all have different kind of outdoor conditions, be it PM1, PM2.5, or even this SO2, NO2. And with that, then we will depend on the indoor applications, whether is it for comfort applications or is it for clean room or healthcare. That because for this many different kind of indoor application, they have different kind of requirements. Yeah, and a different kind of air change that you need to calculate for to meet their ISO clean room level. Yeah, so that is a very basic. I mean, that's the very first initial study that we have to do to find out more in depth on the client needs and the current conditions. Yeah.
Right. So the follow-up would be, can these filters be retrofitted into existing AHUs?
Oh yes, of course. I think this is a very good question because most of the time when the AHU was built and already installed at site, uh, to change the AHU is almost impossible. So Camfil, being the uh, clean air solution leader, we actually have various solutions where we can just take out your current AHU filters, whether is it particle filters, and we just fit in our two-in-one solutions, which is particle followed by which is a particle with the carbon filters to trap the respective content pollutants that you want to target. So yes, you don't have to do any modification on our AHU.
Right.
We will just take out the filters and we have to put in the new filters from Camfil, the two-in-one solutions. Of course, the static pressure, the pressure loss have to be calculated wisely as well. Yeah, and then we have to see whether your AHU is running on a VST, what kind of buffer do we have on the VST? Yeah.
So that's good that even the existing building stock can benefit from this new technologies. Now, what are the benefits of using a filter from ISO 16890 versus ISO 121-3?
Okay. I think first thing first, the ISO 16890 is actually referring to particle filtration standards, whereas this ISO 121-3 is actually referring classification of molecular filters. So these are all two separate uh, application and classifications. So the benefit of abiding to this standard is, of course, you are actually following the latest industry standards, where it's globalized and is more recognized, and so that whether your plant or your facility is in Singapore, is in Europe, or is in the US, we are all talking about the same standard. Yeah, rather than US talking another standard, Europe another standard. Yeah.
Okay, it's good. Now, we have about 5 minutes left and a couple more questions to go through. So one next question would be, if you compare these filters with MERV rating, what would be the comparison?
Uh, Correct me if I'm wrong. I think in this case, we are actually diverting to particle filters because MERV is actually also a particle filtration standard, but it's actually based on American standards. So um, MERV, actually, or they call it S3, S3 52.2 standard, actually is referring to the particle, the test method actually is very broad. They based on 3 different sizes of particle size from zero point 0.3 to 1, 1 to 3, and 3 to 10 micron particle micron. So whereas for ISO 16890 to is more specific and more focused in whereby they actually target on one single size, PM1, PM2.5, and PM10. So if you were to talk about the S3 52.2, where you talk about particle size from 1 and particle size of 3 microns, different filters have different performance. And if the filters perform very well in trapping the 3 micron size, it might be still classified as a high filters, even though when it comes to the one micron size, one micron particle size not doing so well. So it's not very specific. Yeah.
Okay, so it's difference in standards of testing, which brings us to the next question from Jai. Joe, in your test, did you use constant power to test the efficiency for all the gases and particulate matters?
Constant power. I doesn't. I'm not. I do not understand. What do you mean by constant power?
Jai, would you like to key in a bit of clarifications in the Q&A while I take one other question while we wait for that clarification? I guess the next question from the pre-registered audience would be, are there any regulations on air quality in buildings, in particular for schools?
Oh, okay. Let me see. Yes. Definitely, yes, there is. NEA actually came out with a guideline providing the various limits to meet the acceptable IAQ, indoor air quality. So definitely there is. If you want to know more details, do visit the NEA website to find out more on the school environment. Yeah.
Okay. All right. So I guess that brings us to the close of our masterclass today. I think we all have learned something. I know certainly I've been updated on the latest standards and all. So thank you very much, Joe. Would you like to give any final words to our audience here, perhaps on the importance of the CAO?
Yes, there's actually totally no harm to be join us to be one of the CAO or even an AO in your organization, because you will only benefit where the staff will have a employee welfare, where when they have a good IAQ and actually bring them higher productivity and lower absenteeism. So being a CAO and AO actually provide you a lot of resources to the IAQ matters, and also to on your update on what is the current, what is the latest industry standard, what kind of, what is this guy doing to improve the current IAQ in the office, all this. So very informative. It's a very informative panel for you guys to join.
All right. With that, we come to the close of today's masterclass, and we thank everyone for joining us here today. Don't forget to check out BEX Asia's social media page to find out more about our upcoming masterclasses in May, as well as bookmark the dates 6 to 8 September as BEX Asia returns at Sense Expo and Convention Center, and where you'll also be able to meet Camfil, who's one of our key exhibitors in BEX Asia. Thank you, Joe. Thank you, everyone. We wish you a good afternoon and pleasant rest of the week ahead.
Thank you, everyone. Thank you.
Thank you, Joe.